everybody, and welcome to this episode from Code Pickles. This video will see a quick and general overview of object-oriented programming in Java, and will cover the main concepts. As prerequisites, you need to have some basic knowledge related to programming. You need to be able to manipulate variables, data types, loops, and functions. So in this video, we'll introduce the concepts of classes and objects, constructors, abstractions, and interfaces. In programming, a class is compared to a mold that will help us make copies of objects having the same structure of the mold. Usually we say a class and instances of the class, the mold, and the objects. Let's go to Eclipse and do some coding. I've created here an empty project in which we have the main class and the main method. As you know, each program has an entry point. Here, for example, the entry point of the program is the main method. So every instruction executed here, it will be the start of the executions of the program. We'll start talking about classes. As we said, that classes are like molds that have structure, and copies are created based on the same structure. As example, here we'll create a new class person. The class person is public. It has attributes like first name and last name. For example, public string first name, public string last name. The keyword public means that they are visible in other classes. So if you go back here to the main class and we create a copy of the mold that's person, so we create an exact object of the person. For example, if we create a person A and we make an instance of the person, the keyword new means that we created a copy of the same structure of person. We can give it values to the attributes a.firstname, for example, equals Bill, a.lastname equals Gates. So this is a copy mold A of the person that has the same mold of the class person. If you create another copy, person B equals new person, the dot states that we can access the variable first name, b.firstname equals Steve, and b.lastname equals Jobs. So if we modify the structure of the class person in a way to add a method, for example, display, let's call it display, that prints to the console the first name and the last name. First name, the modification of the structure will be applied to the objects as well. So all the objects of the class person will now have a method display that prints the attributes first name and last name to the console. For example, the object A, let's call from the object A the method display, which appears now, and from the object B, let's call it as well. We run the main method and it prints out to the console the first name and last name of the objects A and B. Let's talk now about constructors. As we said previously, each program has its entry point. The class as well has its entry point, and it's called a constructor. A constructor is a method with the same name of the class and has no return type. For example, here, public person is a constructor, and I'll put in it an instruction that prints a message that says the entry point of the class. If we go back to the main method, we see that object A and object B, when calling the new person, they're calling, in fact, the constructor. They're executing the constructor. When I run the program, it prints twice the entry point of the class. One for the object A and one for the object B. Now let's go and add another constructor for the class person, but with different parameters. Let's say now I want the class to get the values of the first name and last name from the parameters of the constructor. I put two variables, string fname and string lname, and say inside the method that the attribute first name gets its value from the parameter fname, and the attribute last name gets its value from the attribute lname. Now I can change in the way that person B can call the constructor with the two parameters, like Steve and jobs. In this way, when executing, the first object A calls the first constructor while printing the entry point of the class, and the second just displays the values that he got from the constructor. The next topic we'll be talking about is the inheritance. A class can inherit attributes and methods from a superclass. I create here a class student, for example, and this class student, when I make it extends person, and I go and create a new class student C equals new student, here for example, we can see here that if we go and put C dot, that the first name and last name and the method display, which are public attributes, are inherited automatically by the class student because of the keyword extends. A student has a first name and a last name. But if we put in the class person a private attribute, which is age, we can see that in the main class, the C dot doesn't inherit the age. So a class inherits public and protected variables. So there are protected, another keyword for the attributes, which is protected here. Okay, we can see that if we put protected age and go to the main method, we can see that the C.age is inherited as it is protected, but it doesn't inherit the private attributes. What happens to the constructors? If we want to pass the first name and last name in the students, like the person B, we need to override the constructor of student and create a constructor, public student, with the parameters string fname and string lname. And in the first instruction, we should call the super constructor, super with fname and lname. In this way, we call the constructor of the class person that has the two parameters. If the student has an additional attribute like student ID, for example, int student ID, And we want to pass it as well in the constructor. Let's say int id, and then we can, in the second instruction, we can assign the value id to the student id. Student id equals id. The class student can have additional methods like public void study, and this method may display to the screen, like for example system.out.println the student plus id plus studies. Here it gave an error because there's no empty constructor in the class student, so we need to fill it. For example, like Elon Musk, and with the ID, which is 1, for example. And if we call c.display, it displays the name, and c.study, it displays the method written in study. Here, for example, there was an error, student ID, the name of the variable. So now if we run the program, it prints the first name, last name, and calls the method study that prints the student ID. Now we'll go deeper and talk about abstract classes. An abstract class is a class that contains abstract methods and non-abstract methods, but we cannot instantiate it. So, for example, if we create an abstract class, activity, public, abstract class activity, and put in it a method, public, abstract, void, sports, for example. An abstract method just contains the declaration of the method. It doesn't contain the body. A body is defined with the curly brackets, so we have to remove these curly brackets to make it abstract. As we said, an abstract class can contain abstract methods and non-abstract methods. So the activity would be reading. Another activity, non-abstract, would be reading. Public void reading, with the curly brackets, with the content system.out.println the person reads. Now, if we want to make the class person extend activity, it needs to have the implementation of the abstract methods. In this way, we have to implement the method sports. For example, sports here, system.out.println this person plays basketball. The last topic is about interfaces. An interface is an abstract class in which all methods are abstract. Let's create an interface. We call it engineering. While defining the methods, we don't need the abstract keyword. So public void problem solving. And as it is abstract, we don't need the content, so we don't need the curly brackets. Let's say a student now implements an interface. A class can extend another class and implement multiple interfaces. So here the class student can implement the interface engineering. As it implements the engineering, the class student must implement the functionality of the class problem solving. For example, here it does some stuff like system out println and solves complex problems. So here comes the end of the video, and the challenge is completed as you managed to make an overview of object-oriented programming in less than 15 minutes. Thanks for watching, and we'll see you in the next video.